So this is your CAP5 test question 3. Describe how oxygen in the air reaches capillaries surrounding the alveoli in the lungs. Details of breathing are not required. So we just need to remember where we are in this system. So we've got trachea, bronchi, and kind of bronchioles, and then alveoli there, and these are contained within lungs. And alveoli, if you focus in on one of these alveoli, then it's talking about the air inside there, and then we've got a kind of blood supply capillary with blood going there. So that's the sort of thing that we are talking about. And first of all, we need to just sort of describe from the outside air where the air is coming from. So we're going to say air from the outside down the trachea, bronchi, bronchioles, then alveoli. That'll do us for starters. How does it get there? Well, it gets there when you expand your chest, your thorax, increase the volume, decreases the pressure, and air will rush in. So it says details of breathing are not required. So I'm just going to put down a pressure gradient. So your diaphragm would flatten, your ribs would go up and out. That would increase the volume of your lungs and decrease the pressure, and so air would go down that pressure gradient. And then we just need to describe how the oxygen in the air reaches the capillaries. And so that's not going to be down a pressure gradient anymore, that's going to be down a diffusion gradient from high to low. So from alveoli to the capillaries down a diffusion gradient. And where is this going? This is going across the epithelial cells of the alveoli and across the capillary endothelial cells. So across alveolar epithelium, and then across the walls of our capillary, so our endothelium, then across capillary endothelium. So we just need 4 out of those. Here are some terms that you don't need to know, but you can apply your knowledge, your existing knowledge to. AO2. Forced expiratory volume is the greatest volume of air both can breathe out in 1 second. And vital capacity, forced vital capacity is the greatest volume of air a person can breathe out in a single breath. So those two are different. Our normal group are group A, so those are healthy, and the other two have a couple of different conditions. First job, calculate the percentage drop in FEV for group C compared with healthy. Right, whereabouts do we choose for this this line? We have to go back to the question, FEV, what's that? Greatest volume of air that person can breathe out in 1 second. So 1 second, let's just highlight 1 second on here. So there's 1 second. Group C, after 1 second, what have we got? We take that across there and it comparing against the healthy, going across there. So this is the volume of air breathed out in 1 second. So that's our forced expiratory volume. Values here for A, so each square is 0.2, so that's 4.2, and group C, that is maybe 0.8, 0.9, I'll call it 0.9, 0.9, let's see. So percentage drop. So remember, percentage change is the change divided by the start times by 100, and that's always the same equation. So the change is 4.2 minus 0.9 over the start. It says drop compared with the healthy, so compared with our healthy, that's our starting value, times by 100. So calculator, 4.2 minus 0.9, 4.2 minus 0.9, so that's 3.3 divided by 4.2 times by 100. So divided by 4.2 times by 100 is 78.5. So 78.5, and that's a percentage. You might have got something slightly different if you read these off. The mark scheme actually gives a sort of 80%. It says about 80% for that, so well, we're absolutely fine there. So quite a lot of work for 1 mark there. Asthma affects bronchioles and reduces the flow of air, and fibrosis, it does not affect the bronchioles, it reduces the volume of the lungs. So on this diagram here, we've got the volume is the kind of total number. So group A have got a huge volume, and the kind of flow is the kind of how fast the line goes up. How steep is the line? That's how fast it's going in or out. And so fibrosis, it says fibrosis does not affect the bronchiole, so it doesn't affect the steepness of the line, but it affects the volume. So as we can see right here at the end, group B have got a lower volume than group C, and group B can also get air in and out pretty quick. So group B haven't got asthma because they've got a pretty steep line, but they've got a lower volume than group C. So we're going for B because first of all their FEV is good, so they can, FEV is good, or alternatively another way of saying that is they can breathe out quickly, can breathe out quickly, and from that we can say that their bronchioles are not affected. Their bronchioles are still wide, they're not affected. So bronchioles are okay, so they're not affected. And the other bit of evidence is that, well, they've got a lower volume. So the FVC, the forced vital capacity, is lower. Or alternatively, say the total volume is lower. Total volume breathed out is lower.